If you think Earth is big, this video is about to embarrass that feeling in the nicest way possible. Subscribe, because in a few minutes, Earth won't just look small, it will look almost unreal. We're gonna zoom out step by step from Earth to the edge of the observable universe. And along the way, you'll see the one question that hits hardest. If Earth is that tiny, why is it the only place we know that's alive? Start with something you already know. Your street, your city, your country. From there, Earth feels huge. It holds oceans, storms, mountains, and 8 billion people who all somehow think they're the main character. Earth is about 12,700 kilometers wide. That number means nothing until you compare it to something. So let's compare, calmly, like we're doing a science report, but one that messes with your feelings. First, the moon. The moon is about 3,400 kilometers wide. Earth is roughly 4 times wider. If Earth was a big exercise ball, the moon would be a tennis ball. When you see the moon in the sky, it looks big, but that's because it's close. The moon is a small world, and it still has mountains and craters and a history written on its face like a bruise that never healed. Now, pull back a little and bring in the Sunday. Here's where your brain starts to complain. The sun is about 1.4 million kilometers wide. Earth could fit across the sun about 100 times. And if you packed Earths inside the sun like tiny marbles, you could fit about 1.3 million Earths in there. That's not poetry. That's just volume. A lot of people hear that and go, okay, cool, the sun is huge. But the real shock is not size. It's what that size does. The sun is so massive, it holds almost all the mass in the solar system. The planets, moons, asteroids, comets, all of it are basically leftovers swirling around the main pot. And the sun is not just a glowing ball, it's a working machine. It has storms bigger than Earth. It throws out solar flares and waves of particles that can slap Earth's magnetic field like a drum. NASA watches this constantly because solar weather can mess with satellites, radio, power grids, and astronauts. The NASA Solar Dynamics Observatory is basically a 24-hour security camera on the Sunday. Now, let's zoom out again, because the sun isn't floating in a neat little bubble. It's the center of a huge neighborhood we call the solar system. The solar system is not the planets and that's it. It's the planets plus a wide field of smaller stuff. Asteroids in the asteroid belt, ice bodies in the Kuiper belt, long-period comets that come from a distant cloud far beyond Pluto. NASA's New Horizons spacecraft gave us a close look at Pluto and the Kuiper belt, and what it showed was simple. The outskirts are not empty. They're full of worlds. Now think about the scale again. Earth to the sun is 1 astronomical unit, about 150 million kilometers. Light takes a little over 8 minutes to travel that distance. That means when you see sunlight, you're seeing the sun as it was 8 minutes ago. 8 minutes sounds small until you remember that this is the speed limit of the universe. Light is the fastest thing we know. So if light needs 8 minutes just to get from the sun to Earth, the solar system is already bigger than your instincts. Here's a fun, slightly scary thought. If the sun vanished right now, you wouldn't know for 8 minutes. You'd still see sunlight. You'd still see a blue sky. Then the lights would go out and gravity would stop holding Earth in orbit and everything would get very quiet in a very final way. That's not to freak you out, it's to show you what distance really means. Now zoom out to the outer planets. Jupiter is about 11 times wider than Earth. It's basically a failed star in the sense that it's a giant ball of gas and storms. And if it were much bigger, it might have ignited fusion and become a small star. It didn't. So it stayed a planet, and it rules the solar system like a bouncer. Jupiter's great red spot is a storm bigger than Earth. Let that sit in your head. A storm bigger than your whole world. And Jupiter is not even the biggest thing in the universe. Not close. Saturn is famous for its rings, but the rings are thin. The drama is wide. The thickness is tiny. That's a life lesson if you want one. Looks huge, might be fragile. Now go past Neptune. The sunlight out there is weak. Space is colder. Things move slow. And beyond the Kuiper belt, you're entering the place where the solar system stops feeling like a family and starts feeling like a rumor. This is where Voyager comes in. NASA's Voyager 1 was launched in 1977. It flew past Jupiter and Saturn, then kept going. It is now far beyond the major planets, traveling through interstellar space. Voyager 1 is one of the most important objects humans have ever built. Not because it's big, but because it's brave. It's a little machine carrying a golden record, still sending back faint telemetry. When people say the universe is huge, Voyager 1 is proof. We have been running for decades, and we are still basically standing at the doorway. So here's Earth so far. Earth is bigger than the moon, Earth is tiny next to the sun, and Earth is basically a speck inside the solar system. But the real shock is coming, because the solar system itself is just one little system inside a much larger thing called the Milky Way galaxy. Before we jump there, let's make one important point. The reason we know these distances and sizes is not because we guessed. It's because humans learned how to measure the universe using light and math, like a ladder. Astronomers built what's called the cosmic distance ladder. It starts with nearby measurements like parallax. If you move your head left and right, nearby objects shift against the background. Same idea, but with Earth's orbit. That's how we get distances to nearby stars. Then it steps up to special stars called Cepheid variables, which Henrietta Leavitt helped make famous by discovering a link between their brightness and their pulsing. Those stars become distance markers. Then it steps up again to supernovae and galaxy redshifts, and suddenly you're measuring the universe itself. It's like using a candle to measure a stadium, then using a lighthouse to measure an ocean. This matters because when we zoom out, we're not doing a cartoon. We're following real methods used by real people and real institutions like the Harvard-Smithsonian Center for Astrophysics and observatories across Earth and space. Now let's zoom out to the nearest stars. The nearest star system to us is Alpha Centauri, about 4 light years away. That means light takes 4 years to travel from there to here. If you could travel at the speed of light, it would still take years. And we cannot travel at the speed of light, not even close. So the solar system is a tiny bubble, and the stars are spaced out like lonely streetlights across a huge dark field. This is where Earth becomes emotionally small. Because Earth is not just small in size now, it's small in reach. Everything we've ever done, every war, every love story, every joke, every song, every heartbreak, happened on one little rock that can't even visit its nearest neighbor star with our current tech. Now, hold that thought, because it sets up the next step. The Milky Way is not a big solar system. It's a city of stars. Our galaxy contains hundreds of billions of stars. Not 1,000, not 1,000,000, hundreds of billions. And around many of those stars, there are planets. NASA's Kepler mission showed us that planets are common, not rare, common. And now, the James Webb Space Telescope is helping scientists study exoplanet atmospheres, looking for molecules that might hint at conditions for life. So here's the uncomfortable math. If even a small fraction of stars have planets, and a small fraction of those planets could be Earth-like, you're still talking about a number that makes your head spin. Earth goes from being a world to being one example. And that's where the big question starts to creep in. If the universe is full of stars and planets, where is everyone? That question has a name, the Fermi paradox, named after Enrico Fermi, who basically asked, in plain language, if life is common, why don't we see it? And that question becomes a shadow that follows this entire zoom out. Because the bigger the universe gets, the louder the silence feels. Now we're ready to hit the next scale jump, the one that makes Earth feel not just small, but almost invisible. We're going into the Milky Way next, then beyond it into clusters of galaxies, and then we're going to the cosmic web, where matter itself forms giant strands like a spider web made of galaxies. And when you see that, you'll understand why astronauts come back quieter than they left. Here's the challenge. Your brain was built to worry about rain, food, and other humans, not galaxy clusters. So as we zoom out, the numbers will try to turn into noise, and your job is to keep them meaningful. To keep it meaningful, we're going to use 3 anchors over and over. 1, size you can picture, like Earth next to the Sunday. 2, distance measured in light time, because light makes distance real. 3, real tools and real missions, like Hubble records, Voyager telemetry, the Keck Observatory in Hawaii, and the European Southern Observatory, because this isn't guessing, it's measurement. Now take a breath, because we're about to leave the solar system behind and enter the Milky Way, where Earth becomes less than dust. Picture the sun as one grain of sand on a huge beach. That's not even the Milky Way yet. That's just one star in a galaxy that holds hundreds of billions of stars. And we live inside that galaxy, so we can't step outside it and take a selfie with it. We have to build the picture from clues, like trying to map a forest while you're standing between the trees. The Milky Way is a spiral galaxy. That means it has arms, like a pinwheel. Our solar system sits out in one of those arms, not near the center. That's good news, by the way. The center of the Milky Way is crowded, violent, and full of strong radiation. There's also a supermassive black hole there called Sagittarius A star. Scientists tracked it for years, and teams like the Event Horizon Telescope helped capture images of black holes in other galaxies, proving these monsters are real and not just science fiction. Now, here's the first mind bender. If you could travel at the speed of light, it would take about 100,000 years to cross the Milky Way. 100,000 years. And light is the fastest thing we know. So when you look at the Milky Way in the night sky, that bright milky band isn't space decoration. It's the edge view of a city of stars, so big you can't even hold it in your head properly. This is where Earth starts to feel less like a planet and more like a tiny campsite in a giant wilderness. And we only know this because we learned how to measure and compare light. The European Southern Observatory, the Keck Observatory in Hawaii, and many other ground observatories map stars, track their motion, and study their chemistry. Hubble helped us see deep into space without Earth's atmosphere messing up the view. The James Webb Space Telescope goes even deeper in infrared, letting scientists look through dust clouds and study galaxies in their early days. All of this matters because when we zoom out, we're not just zooming out in size, we're zooming out in time too. The farther you look, the older the light is. So here's a simple truth that feels strange. The universe has a built-in time machine, and it's just your eyes. Now, let's go bigger than the Milky Way. Our galaxy is not alone. It travels in a small neighborhood called the local group. The local group is basically a small gang of galaxies moving together. The Milky Way and the Andromeda galaxy are the two big ones. Andromeda is about 2.5 million light years away, which is already a number that makes your brain go quiet. 2.5 million light years means the light you see from Andromeda left that galaxy when early humans were still just figuring out how to survive. Not phones, not cities, survival. Also, Andromeda is coming toward us, slowly. Over billions of years, the Milky Way and Andromeda will merge. It won't be a crash like cars. Galaxies are mostly empty space. It will be a long, slow mixing. Stars will swing around new paths. New shapes will form. If Earth still exists then, the night sky will look completely different. It's wild, but it's not scary. It's just gravity doing what gravity always does. Now, zoom out again. The local group is part of something bigger called the Virgo supercluster region. And even beyond that, scientists talk about a larger structure called Laniakea, which is a huge basin of galaxies flowing along gravity like water sliding downhill. That idea is one of the biggest punches to human pride, because it shows galaxies are not just sitting still like decorations. They are moving in giant flows. This is where Earth becomes almost meaningless in size. Earth is a dot around a star. The star is one of hundreds of billions in a galaxy. The galaxy is one of many in a local group. The local group is part of a giant structure of clusters and superclusters. And we're still not at the big picture. Here's the part people don't expect. The universe is not galaxies spread evenly like sprinkles. It's more like a web. When astronomers map galaxies across huge distances, they see filaments, strands, and walls, with giant empty regions called voids. It looks like a cosmic spider web. This is what people mean by the cosmic web. This is where the Vera Rubin Observatory comes in. Rubin is built to scan the sky again and again, catching changes, mapping objects, and building gigantic catalogs. It's basically a reality show for the universe, but in a scientific way. Not one snapshot, continuous watching. And when those maps grow, our place shrinks even more. Now, let's talk about the observable universe. This is not the whole universe. It's the part we can see. Why can't we see everything? Because the universe has an age. Light has only had so long to travel. The universe is about 13.8 billion years old. And because space has expanded while light traveled, the observable universe is much larger in distance terms than 13.8 billion light years. So the observable universe is like a bubble around us. Not because we are special, just because we are here. Now for the part that feels like a slap. In that bubble, there are not just thousands of galaxies, not millions, likely hundreds of billions of galaxies, and maybe more, depending on how you count and how deep you estimate. That means trillions of stars times trillions of stars. The numbers become ridiculous. So Earth goes from big to tiny, then from tiny to basically nothing. And that is where people usually start to feel either panic or peace. Some people feel panic because small feels like meaningless. But here's the twist. Small does not mean worthless. A diamond can be tiny and still be priceless. Earth is tiny, but it's the only place we know that has life. Not just life, but life that can ask questions. Life that can build telescopes. Life that can look at the cosmic web and say, wait, we're part of that. That's the part that makes the zoom out hit emotionally, because it turns into a question that feels personal. If the universe is so huge, why are we alone right now? That's where the Fermi paradox steps back in. Enrico Fermi basically asks the simplest question with the biggest shadow. Where is everybody? There are many possible answers. Maybe life is rare. Maybe life is common, but intelligence is rare. Maybe civilizations don't last long. Maybe they don't broadcast. Maybe they are out there and we just don't know how to listen. Arecibo used to be one of the most famous radio telescopes for listening and sending signals. Even though Arecibo collapsed, its legacy data still matters. And the idea of searching the sky for signals continues in different ways. People also talk about old concepts like Ronald Bracewell's ideas about communication and probes, not because it proves anything, but because it shows how long we've been thinking about contact and silence. And yet, the silence is still the loudest thing. So now we've reached a point where size and meaning collide. Earth is almost invisible on the scale of the cosmos. But Earth might be unbelievably important because it may carry something rare, a conscious viewpoint, a witness, a place where the universe is not just happening, but being understood. And that leads to the hardest thought in this whole story, the one that makes people sit back and stare at the wall. What if the universe is full of wonders, but almost no one is awake to see them? What if consciousness is the rarest thing? Not planets, not stars, not galaxies. And if that's true, then the responsibility gets heavy. Because if Earth is one of the only places where the universe is being noticed, then protecting Earth is not just about humans. It's about protecting a spark of awareness in a huge, dark ocean. Now, we're not going to turn this into a sad lecture, but we are going to be honest. We are fragile. Our planet is thin-skinned, a thin atmosphere, a magnetic field that shields us, a careful balance of temperature and chemistry. The kind of balance NASA studies every day through Earth-observing satellites, climate measurements, and space weather monitoring. So the zoom out does something strange. It makes you feel small. Then it makes you feel responsible. Because you realize how rare home might be. And we still have one final zoom out that changes everything again. Because we haven't talked about the oldest light in the universe yet, the light that comes from the early universe itself. That's where the story becomes almost unbelievable. Because the farther out we go, the more we start to see the universe as it was near the beginning. And when you see that, Earth doesn't just look small. It looks like a miracle that learned to think. Now we're going to the edge of what we can see. And this is where the universe stops feeling like space and starts feeling like a deep story written in light. Because when you look far enough out, you don't just see far away things. You see the past. Every step outward is a step backward in time. Light needs time to travel. So the farther something is, the older the image you get. That means your eyes, your telescopes, and every space observatory NASA has launched are basically time machines that work one way. They show you what used to be. So what happens when you look so far out that you reach the earliest light the universe still has? You hit something called the cosmic microwave background. It's basically the leftover glow from when the universe cooled enough for light to move freely. Before that, the universe was like thick fog. Light couldn't go far. It kept getting scattered. Then the fog cleared, and the light from that moment has been traveling ever since, stretching as the universe expands. This is not a small detail. It's one of the biggest proofs we have that the universe had a hot beginning and has been expanding. It's also why maps of the cosmic microwave background look like tiny temperature freckles across the sky. Those freckles are the seeds of everything. The little differences in density that later grew into galaxies, clusters, and the cosmic web. When you understand that, the cosmic web stops being a pretty pattern and becomes a consequence. It's gravity doing its slow work for billions of years. Now, let's tie this to the tools. NASA missions like WMAP and the European Space Agency's Planck mapped the cosmic microwave background in incredible detail. Those maps aren't just pretty. They tell scientists about the age of the universe, its composition, and how it evolved. They help us estimate things like how much normal matter exists, how much dark matter exists, and how much dark energy seems to be driving accelerated expansion. Yes, dark energy is a real thing in the sense that we have strong evidence something is pushing the expansion faster over time. No, we don't fully know what it is. That's one of the biggest unsolved problems in all of science. And here's where Earth shrinks again, because now you're looking at the universe not as a bunch of objects, but as a whole system. A system with rules, a system with an age, a system with a story arc. And in that story arc, Earth is a late arrival. A tiny detail near the end of a long chapter. Now we have to talk about the deepest zoom out feeling of all. The first stars, there was a time when there were no stars at all. Just hydrogen, helium, and darkness. Scientists call it the cosmic dark ages. Then gravity pulled gas together. The first stars formed. They were likely huge, bright, and short-lived compared to our Sunday. They cooked heavier elements in their cores and then died, often exploding and spreading those elements into space. That's the origin of everything you care about. The oxygen you breathe, the iron in your blood, the calcium in your bones, all of it came from stars. Not just from one star, but from generations of stars living and dying and enriching space with heavier elements. Earth could not exist in the early universe. Life as we know it could not exist. There wasn't enough chemical variety yet. So the fact that you are here now means you are living in a universe old enough to have built the ingredients. That's another quiet miracle people forget. You are not just small. You are made of rare stuff that took time to create. Now, bring in the James Webb Space Telescope. James Webb looks in infrared, which helps it see ancient galaxies whose light has been stretched into longer wavelengths by expansion. Webb has been finding very early galaxies and surprising astronomers because some seem bright and structured earlier than expected. That doesn't mean the Big Bang is wrong. It means the early universe may have grown complex faster than we assumed, and our models need updates. This is exactly how science works. The universe shows you something. You adjust. You test again. And this is where the scale conversation changes. Because now the universe isn't just big in distance, it's big in time. 13.8 billion years is not just a number. It's the amount of time gravity had to sculpt everything. It's the amount of time chemistry had to get interesting. It's the amount of time life may have had to start somewhere else too. And that brings the Fermi paradox back again, but now it hits harder. If the universe has had that much time, why don't we see clear evidence of other civilizations? One possible answer is distance. Even with fast ships, space is huge. Another answer is time mismatch. Civilizations might rise and fall like brief sparks. You might have a million-year gap between two civilizations, and they never overlap. Another answer is that intelligence might not spread. It might stay local. It might choose quiet. It might not want to broadcast, or it might use methods we don't recognize. This is why people keep searching. The old Arecibo message was one attempt to say, "We are here." It's also why radio astronomers still analyze sky surveys, and why ideas like Ronald Bracewell's concept of automated probes get discussed in science communication. Not because anyone has proof, but because humans are trying to think like the universe is bigger than our habits. Now let's land this in a way that keeps it relatable. Imagine you are on a beach at night. You can see lights far away along the coast. Those are other people. Now imagine the coast is so long you can't see the end, and the lights are so far apart that you might stare for years and still see nothing new. That's what the cosmos can feel like. Not empty because nothing exists, empty because it's too big. Now, here's the key moment in the zoom out story. At the largest scale, the universe may contain regions we will never ever reach. Not because we are too slow, because space itself is expanding. Some galaxies are moving away from us so fast that their light will never reach us in the future, even though we can see their old light now. That means there are parts of reality that are, in practice, cut off. So when you ask, how small is Earth? The answer isn't just tiny. The answer is tiny and locked in a bubble of observable space. That sounds depressing until you flip it. If we are in a bubble, then what we do inside the bubble matters even more, because this might be the only bubble we ever get to influence. Now, after all that scale, after all that cold distance in ancient time, we need to come back to the emotional center without getting cheesy. Because the point of this video is not to make people feel worthless. The point is to make people feel awake. Earth is small, but Earth is home. Earth is the only place we know where the universe has produced beings that can measure it, that can build telescopes, that can send probes like Voyager, that can run observatories like Keck, that can launch machines like Hubble and James Webb and actually understand the signals. If you think about it, that's insane in the best way. A tiny planet in a giant galaxy, in a cosmic web, in an expanding universe, produced a creature that can look back at the beginning and say, I think I understand what happened. That's you. And now we're approaching the final part of the story, the part that turns the zoom out into a personal conclusion. Because once you accept how small Earth is, you're forced to answer one question. So what do we do with that knowledge? Some people use it to feel hopeless. That's a mistake. The better move is humility and responsibility. Humility because you are not the center. Responsibility because you might be rare. So let's bring this back down from the edge of the universe to the only place any of this actually matters. Earth. Not as a blue marble poster, as a working, breathing place. Earth has an atmosphere that is thin enough to be scary when you think about it. If you could drive upward for about an hour, the sky would already start turning dark. Keep going, and the air becomes so thin it stops being air. That thin layer is the difference between alive and dead rock. It holds heat, blocks a lot of harmful radiation, and lets liquid water stay on the surface. And it's not just the atmosphere. Earth has a magnetic field that acts like a shield. Without it, the solar wind would slowly strip away the atmosphere, the way it likely did to Mars over time. NASA's MAVEN mission has studied how Mars lost much of its atmosphere, and it's a reminder that planets aren't just places, they're systems. They can fail when you look at Earth like that. It stops being small and starts being precious in a very practical way. Now, the zoom out story also teaches you something about how rare normal might be. We used to think planets were rare. Then NASA's Kepler mission showed us planets are everywhere. Thousands confirmed, and many more likely. Some are giant gas worlds hugging their stars. Some are rocky and scorched. Some might be ocean worlds. Some might have weird weather that makes Earth look calm. And with the James Webb Space Telescope, we're starting to get a better look at atmospheres of some exoplanets. Not perfect, not complete, but enough to see that other worlds are chemically alive in their own ways. Some have clouds of sand or glass. Some have thick hazes. Some might have water vapor in the right conditions. So you get this strange mix of feelings. On one hand, planets are common. On the other hand, Earth-like life is still unconfirmed anywhere else. And that's where the emotional weight comes from. Because you can't help asking, if the universe can build so many planets, why haven't we found another Earth with oceans and biology and creatures making jokes? That silence can mean many things. And this is where people's brains usually do one of two things. They either jump to we're alone forever, or they jump to they're hiding. Both are emotional shortcuts. The honest answer is simpler and more annoying. We don't know yet. Space is huge, and our search is still small. We have searched only a tiny slice of the sky in a tiny range of frequencies for a tiny amount of time. The idea that we would already have a clear signal is like dipping a cup into the ocean and saying, no fish here. Radio searches have been done for decades. Arecibo played a huge role in that era, and even though it's gone, that legacy of listening is still part of modern work. But the universe doesn't owe us an easy signal. Civilizations, if they exist, might not use radio much. Or they might use it briefly and move on. Or they might point their signals inward, not outward. Or they might communicate in ways we haven't guessed. That's the Fermi paradox in street language. The universe looks like it should be crowded, but it sounds quiet. Now, here's another angle that makes the silence feel different. Time, we are alive now, in this specific window. The universe is 13.8 billion years old. Our radio technology has existed for a bit over a century. That's a blink. If another civilization had a radio phase 1 million years ago, we missed it. If they'll have it 1 million years from now, we'll miss it too. Two ships passing in a cosmic night. Not because they're not there, but because the timing doesn't overlap. So maybe the universe is not empty. Maybe it's just unsynced. And if that's true, then being alive right now becomes even stranger, because we are the universe, waking up in one spot at one time and realizing it exists. That's not a spiritual line. That's a straight observation. You can't find meaning with a telescope, but you can find facts that make your feelings wobble. Here's one of those facts. Everything you've ever touched is made from atoms that were forged in stars. The early universe had mostly hydrogen and helium. The heavier elements came later from star deaths. That means planets like Earth, with rock, metal cores, oceans, and chemistry rich enough to build life, are only possible in a universe that's had enough time to manufacture ingredients. So you are not just small in a big universe. You are late in an old universe. And being late is a gift, because it means you have the ingredients and the stability to exist at all. Now, the zoom out also teaches you something else that people miss. Most of the universe is not even the kind of matter you're made of. Normal matter, the stuff that makes stars and planets and you, is only a small fraction of the universe's total energy budget. Dark matter and dark energy dominate the big picture in ways we're still trying to understand. We know dark matter has gravity because galaxies rotate the way they do, like something invisible is adding mass. We know the universe's expansion is accelerating, which points to dark energy or something like it. But we don't have a neat, here it is in a jar explanation. So the universe is not only huge, it's also partly unknown. Even with all our telescopes, we're still like kids with a flashlight in a gigantic warehouse, proud we can see the shelves, but not yet sure what the building really is. And that brings the story back to Earth again, because Earth is where the questions live. Earth is where the instruments are built. Earth is where the data is interpreted. Earth is where curiosity evolved. You can think of Earth as tiny and still accept that it has a huge role in one sense. It's the only known place where the universe is being studied by the universe. That sounds like a riddle, but it's just reality. Now, when people hear that, they often drift into a dreamy mood, which is fine, but let's keep it grounded. If Earth is rare, then it's fragile. If it's fragile, then it matters how we treat it. If we want to spread life beyond Earth, it's not a movie montage. It's a hard problem. Space is hostile. Radiation, vacuum, distance, time, psychological strain. Even getting humans safely to the moon and back took enormous effort, and NASA is still solving the long-term problems of living in space through the Artemis program and research on the International Space Station. And if you go farther, like Mars, the challenges multiply. So when the video ends with "maybe we should spread life," that isn't a fantasy line, it's a challenge line. Because if we are rare, then we carry a responsibility that's not about ego, it's about protection. Protection of the only known living world. And protection of the only known place where awareness exists, at least as far as we can tell. That's heavy, but it's also motivating because it turns the zoom out into something useful, not fear, not despair, perspective. And perspective is powerful because it changes what you take seriously when you wake up tomorrow. You might still have bills and stress and drama, but now you also have this quiet truth in your pocket. You live on a tiny world in a universe that is unimaginably big. And yet, somehow, this tiny world learned how to look outward and measure the whole thing. That is the kind of smallness that doesn't shrink you. It sharpens you. When you sit with that for a minute, something interesting happens in your head. At first, the scale makes you feel small. Then, after a while, it makes you feel focused. Because when Earth becomes a dot in a cosmic ocean, a lot of the loud stuff we argue about starts to look kind of silly. Not all of it. Pain is real, hunger is real, love is real. But a lot of ego drama shrinks fast when you remember how rare a thinking planet might be. And that's not just a feeling. It connects to real science in a surprisingly practical way. For example, the reason we can even talk confidently about Earth's place in the universe is because humans built measurement systems that work at wildly different scales. The same physics that describes a falling apple helps describe a planet's orbit. The same light that warms your skin carries information from galaxies billions of light years away. The universe is one set of rules acting on different sizes. That idea alone is one of the most comforting things in science. It means the universe isn't random noise, it's legible. And we are learning to read it. Now, let's zoom in just a little from the biggest picture to something humans can relate to again. Stars. When you look up at night, stars look like tiny dots. But stars are not dots. They are giant balls of hot gas, many of them far larger than our sunday. Some are so big that if you drop them where our sun is, they would swallow the orbit of Earth and then keep going like it wasn't impressed. There are stars like Betelgeuse, a red supergiant in the Orion area of the sky, that could reach out past the orbit of Mars if it were placed in our solar system. And Betelgeuse is just one. There are even bigger ones. That's the universe basically saying, you think your biggest is big. Cute, and yet, here's another twist. Big stars live fast and die young. Small stars can live for a very long time. Our sun is middle-aged by star standards. It has about 5 billion years behind it and roughly 5 billion years ahead before it expands and changes drastically. That timeline matters because life needs time. Complex life especially needs stability over long periods. So even though huge stars are impressive, they are not the best homes for long-term life the way we imagine it. They burn bright and then go out dramatically. That's beautiful, but it's not calm. Now take that to galaxies. Galaxies are made of stars, gas, dust, and dark matter. They collide, they merge, they evolve. And they're not all the same. Some galaxies are spiral, like the Milky Way. Some are elliptical, like giant glowing footballs. Some are irregular and messy. The James Webb Space Telescope has been showing us galaxies in their early forms that look different from what we expected, which reminds us again that our normal picture is based on a limited view. And somewhere in all of that, there are planets. This is the part where the numbers get so big, people start to stop caring because their brain can't hold it. So let's keep it simple and visual. Imagine a city with 100 billion houses. That's like the Milky Way with stars. Now imagine that a lot of those houses have rooms. That's like planets. Now imagine that in a tiny percentage of those rooms, a candle is lit. That candle is life. We don't yet know how many candles are lit. We only know one is lit for sure, ours. Now, When you accept that, you understand why scientists are so obsessed with exoplanets in atmospheres. It's not because they want to prove aliens exist for a headline. It's because atmospheres are clues. An atmosphere tells you what's happening on a planet. For example, oxygen is reactive. It doesn't hang around easily unless something keeps making it. On Earth, life makes and maintains a large amount of oxygen. So if you found a planet with a strong oxygen signature and certain combinations of gases, it might be a sign of life. Not proof, but a reason to investigate. That's why James Webb's ability to study atmospheres is so exciting. It's like finally having better ears in a quiet room. And it's also why the Keck Observatory and other big telescopes on Earth still matter. Ground telescopes have been detecting exoplanets and measuring their properties for decades. Space telescopes and ground telescopes work like a team. Now, let's talk about the honest difficulty of this search, because it connects to that silence again. Even if a planet has life, it might be simple life. Microbes, oceans of chemistry with no cities. Even if a planet has intelligence, it might not build radios. Even if it builds radios, it might not broadcast into space. Even if it does broadcast, those signals weaken with distance and get buried in cosmic noise. So the silence doesn't automatically mean nobody's there. It can mean we are early, or we are listening wrong, or the universe is a lot quieter than movies. This is where the human part of the story comes back again, because humans have always tried to place themselves in the center. Ancient models put Earth at the center because that's what it feels like. The sky moves, we don't feel Earth move, so it feels like Earth is the still point. Then science showed us Earth rotates and orbits the Sunday. Then we learned the sun is one star among billions. Then we learned the Milky Way is one galaxy among countless galaxies. Each step removes us from the center. And instead of making us worthless, it makes us more honest. It makes us see that center is a human concept, not a cosmic one. In the observable universe, there isn't one center you can point to like a dot on a map. Everywhere sees itself as central in terms of what it can observe, because the observable universe is defined by where you are. Move somewhere else, you get a different observable bubble. That's why arguing about the center of the universe is like arguing about the center of a horizon. The horizon follows you. Now, hold that idea, because it changes how you think about meaning. Meaning doesn't come from being central. Meaning comes from being conscious. You can be tiny and still be the only known place where the universe is being understood. So the big picture becomes strangely personal. If Earth is the only known thinking world, then your daily life is happening on the rarest kind of place we know exists. A place that produces minds. A place that produces science. A place that produces music and jokes and dreams and questions. That makes even ordinary moments feel different. A child asking why the sky is blue. A teenager staring at the moon. A tired adult looking up after a long day. Those are not small moments in the cosmic sense. They are the universe looking at itself through you. And now, there's another detail that makes the scale feel even sharper. Even if the universe contains trillions of galaxies, the speed of light and the expansion of space mean that travel and communication across the whole thing may be impossible. Not hard, impossible in a practical way. So if life exists elsewhere, it might be separated by barriers that no technology can casually erase. That means being alive here matters because elsewhere may not rescue you, guide you, or even know you exist. You are homegrown. Earth is your only guaranteed ground, which circles back to that earlier conclusion without repeating it too loudly. Small doesn't mean unimportant. Small means you're holding something rare. And rarity changes how you treat things. If you had the only copy of something priceless, you wouldn't leave it in the rain. That's the feeling the scale of the universe is supposed to create. Not fear, not despair, care. Care for the planet, care for knowledge, care for the fact that you get to exist at all. And if you keep that feeling, the universe stops being a cold void and becomes something else. A place that made you, a place you can study, a place you can understand, piece by piece, with patience. Because the universe is huge, yes, but it is also readable. And that means your curiosity is not a joke. It is one of the most powerful things on Earth. Let's get even more real for a second, because Earth is tiny can turn into a slogan if you don't pin it to something you can actually feel. So here's a simple trick. Imagine the entire Earth is the size of a peppercorn, sitting in your palm, small enough to lose if you sneeze. Now imagine the moon is a grain of sand near it. Now imagine the sun is a big grapefruit a few meters away. Already, that's weird. But now keep going. Where is Jupiter in this model? Farther out, much farther. And the Kuiper Belt, where icy bodies hang out, is way out past that. And Voyager 1 inch, this model is still barely leaving the neighborhood, still just a tiny dot drifting away. That's why space travel is hard. Not because rockets are cool, because distance is brutal. Now zoom out from your palm to the entire Milky Way. In this model, your peppercorn Earth is no longer small, it's gone. There is no scale where your hand can hold it anymore. It disappears into the math. This is why astronauts talk about the overview effect. Seeing Earth from space can change how you think, not because it's pretty, but because it's obvious. No borders, one atmosphere, one home. That's a human reaction, but it's built on a real physical fact. Earth is a closed system compared to the size of the universe. Everything you breathe, drink, eat, and build with is cycling inside a thin layer around one rock. We borrow atoms from the same pool over and over. The water you drink has been through countless living things before you. The oxygen you breathe has been part of other lungs before yours. That's not gross. It's just the truth of living on a small planet. So when we talk about Earth's scale, we're also talking about limits. You can't treat a tiny system like it's infinite. Now, to keep the story moving and not turn into a lecture, let's make it even more concrete. Look at the night sky again. You see stars, but most of what's out there is invisible to your eyes. Gas clouds, dust clouds, dark matter, radiation at wavelengths you can't see. That's why we built instruments. Hubble sees in visible and ultraviolet. James Webb sees in infrared. Radio telescopes listen to long wavelengths. X-ray telescopes catch violent high-energy events. The point is, the universe is not just what your eyes show you. It's bigger than your senses. And still, we've learned enough to map the cosmic web. That's the part that should make you proud in a quiet way. Not proud like bragging, proud like, wow, humans actually pulled that off. Now, here's a piece of perspective that keeps viewers hooked, because it's both creepy and true. Most of the stars you see at night are already different from what you see. Some might be dead now, and you just haven't received the news yet. If a star is 1,000 light years away, you are seeing it as it was 1,000 years ago. It could have changed, and you wouldn't know for centuries. So the sky is not a live broadcast. It's a delayed broadcast. And if you want the scariest, honest thought in astronomy, it's this. You are always looking at ghosts, not spooky ghosts, just old light. Now, let's connect that to how humans changed their view of the universe over time. For most of human history, people had no reason to think Earth wasn't the center. It felt like the center. Then the evidence piled up. Galileo used a telescope and saw moons around Jupiter. That was a crack in the old worldview, because it proved not everything orbits Earth. Newton gave us gravity and a set of rules that explained motion. Later, Edwin Hubble showed that galaxies exist beyond the Milky Way and that the universe is expanding. That was a turning point. It meant the universe is not static. It has history. And modern work continues that tradition with institutions and teams that are basically the muscle of astronomy. NASA's Jet Propulsion Laboratory for missions and navigation, big observatories like Keck, organizations like the European Southern Observatory, the Harvard-Smithsonian Center for Astrophysics doing major research. These names matter because they represent one thing. Humans didn't just stare at the sky. Humans built a way to interrogate it. Now, here's a question that keeps viewers glued because it feels personal. If Earth is tiny and time is huge, what are the chances that life like us happens at all? We don't have a clean answer, but we do have clues. Life on Earth appeared relatively early in Earth's history, at least in simple form. That suggests chemistry can start life fairly quickly when conditions are right. But complex life took a long time. Intelligent life took longer. And technology is a very new thing. So even on a planet where life exists, getting to civilization might be rare. This is why the Fermi paradox refuses to go away. It keeps whispering. Maybe microbes are common. Maybe civilizations are rare. Maybe civilizations destroy themselves. Maybe they go quiet. Maybe they are far apart in space and time. And here's the part that hits differently after the zoom out. Even if there are many civilizations, you might never meet them, because the universe is structured in a way that limits connection, not just because of technology, but because of physics. This is why the idea of spreading life beyond Earth becomes a serious conversation, not because we want to conquer space, but because survival on one planet is a gamble. A bad asteroid, a runaway climate shift, a global catastrophe, and the only known conscious life could be wiped out. That thought sounds dramatic, but it's actually calm logic. If you have something rare, you don't keep it in one fragile container. Now, at the same time, this is not an excuse to treat Earth like a trash can because we'll move to Mars. That's fantasy. Mars is hostile. No breathable air, harsh radiation, cold, dust storms. You'd be living in sealed habitats, like a permanent emergency. Earth is still the best planet we've ever seen by a ridiculous margin. So the honest takeaway becomes balanced. Earth is tiny in the universe. Earth is enormous in value. And the reason Earth is valuable isn't because it's bigger or special by location. It's valuable because it's alive. And because it's the only place we know that can tell the difference between alive and not alive. That's the part that should make a person pause. Not because it's sad, because it's astonishing. Now, there's another twist that keeps the story from feeling like a motivational speech. The universe is not finished. Galaxies are still forming and merging. Stars are still being born. Planets are still being built. And new discoveries keep changing what we thought we knew. Every time a new telescope comes online, the universe basically says, you don't know me as well as you think. And that's good news, because it means there's more to learn, more to map, more to understand. If Earth is tiny, then curiosity becomes huge. Curiosity becomes the tool that expands your world without moving your body. And for a viewer watching this video, that's the quiet power. You can live on a tiny planet and still hold the universe in your head, piece by piece, with time and attention. That's not a slogan. That's what astronomy literally does. It lets a small creature understand a big reality. And that is a kind of greatness that doesn't depend on size at all. And here's the funny part. The more you learn about the universe, the more you realize it has zero interest in your confidence. You think you understand it, then a new telescope shows up and the universe goes, that's cute. Watch this. That's basically what happened with Hubble. Before Hubble, our view was like looking through a dirty window. After Hubble, the window got cleaned. And suddenly, we weren't just seeing stars. We were seeing galaxies packed behind galaxies, like the sky had layers. Then James Webb showed up, and it's like the universe upgraded from regular vision to night vision. Webb looks in infrared, which means it can see through dust better, and it can catch older, stretched light from very early galaxies. So the story isn't just, wow, it's big. The story is, wow, it's big, and it has been busy for a very long time. Now, if you want the scale to feel real again, do this. Think of the Milky Way as a single city at night. Lights everywhere, roads everywhere, millions of little stories happening in tiny apartments. Now imagine you fly far enough away that your whole city becomes one glow on the horizon. Now imagine you keep flying and your country becomes one glow. Now imagine Earth becomes one glow. Now imagine the Milky Way becomes one glow. That's what a galaxy cluster is like. Many galaxies close enough to pull on each other with gravity, trading gas, merging slowly, orbiting a shared center like a dance that takes billions of years to finish one move. And here's the creepy, calm truth. A galaxy cluster doesn't care about your timeline. It moves on a clock that makes human history look like a blink. So when we say Earth is small, we're not just saying small in size. We're saying small in influence. If Earth disappeared tomorrow, the universe would not shake. The Milky Way wouldn't even flinch. The cosmic web wouldn't notice. The expansion of space wouldn't pause like a movie waiting for your reaction. The universe would keep going. That sounds harsh, but it's actually useful because it forces you to separate two things. Cosmic importance and personal importance are not the same. Cosmically, Earth is tiny. Personally, Earth is everything. Every laugh you've ever had requires an atmosphere and a temperature range and liquid water and food and people. You can't laugh on a dead rock. You can't cry on a dead rock. You can't fall in love on a dead rock. Earth is small, but it is a stage where the rarest kind of thing happens. Experience. Now let's talk about something viewers love, because it's both weird and relatable. The universe has rules, but it also has habits. Gravity loves to clump matter. That's why you get stars, galaxies, clusters. But the universe also has a habit of making emptiness, giant voids, places so empty that if you live there, the night sky would look almost dead. You wouldn't see the Milky Way as a bright band. You'd see far fewer galaxies. Your whole sense of reality would feel different. So your sky depends on where you live in the cosmic web. That alone is mind-blowing. We live in a region of the universe where matter is clumped enough that the sky is rich and bright. Our view is basically a lucky seat in the theater. And this is why the Vera Rubin Observatory is such a big deal for the future. Rubin is built to scan huge sections of the sky over and over, building a living map of what changes and what doesn't. New asteroids, new supernovae, new distant objects. The universe moving in real time, not just sitting still for a pretty photo. That matters for one reason. It means the universe is not done. It's still unfolding. Now, back to Earth. Because if you leave people floating too long, they drift. One of the strangest things about Earth is that we forget how rare normal feels. You wake up, you breathe, you drink water, you walk outside, you complain about heat or rain, you get tired, you laugh, you scroll, you sleep. All of that is extremely non-trivial in the universe. Most places are frozen, airless, and dead. Even inside our own solar system, Earth is the odd one. We have liquid oceans on the surface. We have a stable climate range compared to a lot of worlds. We have plate tectonics recycling minerals. We have a magnetic field acting like armor. We have the moon stabilizing Earth's tilt enough to keep seasons from going totally wild. It's like a bunch of life-friendly features stacked on each other. So when you zoom out and then zoom back in, Earth stops being just a planet. It becomes a very specific kind of planet, a working one. Now here's where I want the viewer's brain to do a little flip. If Earth is so special, why do we treat it like it's replaceable? I'm not even talking politics. I'm talking common sense. If you had one phone and it was the only phone on Earth that could make calls, you wouldn't throw it at the wall every day and say, I'll get another one later. But humans do a version of that with the planet because our instincts evolved for short-term survival, not long-term stewardship. Our brains are good at noticing immediate danger, like a lion, not slow danger, like erosion, pollution, or a changing climate. And this is where NASA and real science work becomes relevant again in a way that's actually relatable. NASA doesn't only look outward, it looks inward too. Earth-observing satellites track clouds, oceans, ice, heat, and atmosphere chemistry. Not to lecture you, but to measure reality, because you can't protect what you refuse to measure. Now let's tie this back to that other uncomfortable topic without getting weird about it. The search for life. People hear aliens and their brains go straight to movies. But most scientists are just talking about biology, microbes, simple life, the kind of life that changes a planet slowly and leaves chemical footprints in an atmosphere. That's why the James Webb Space Telescope studying atmospheres matters. That's why the Keck Observatory matters. That's why all these institutions matter, because they're not chasing drama, they're chasing evidence. And so far, Earth is the only confirmed example of life. That fact has two possible meanings, and both are heavy. One, life is rare, and we are lucky beyond understanding. Two, Life might be common, but finding it is much harder than we assumed. Either way, the message is the same for how you treat Earth. Don't be careless with the only lifeboat you can see. Now let's talk about the most human part of the whole zoom out story. Humility. Not humiliation. Humility. Humility is when you realize you're small and you stop trying to pretend you're not. It doesn't make you weak, it makes you clear. And clarity is powerful because it changes the kind of goals you respect. If Earth is tiny, then knowledge becomes priceless. If Earth is rare, then kindness becomes practical. If the universe is silent, then protecting your little candle of life becomes the most logical move you can make. Now, one more thought that keeps viewers engaged because it's both comforting and slightly spooky. Even if we never meet another civilization, we can still do something incredible. We can expand the amount of universe that is being understood. Right now, the universe knows itself, as far as we can tell, through us, through minds, through questions, through science. And that can grow, not just by traveling, but by learning. Every time you understand one new thing, your world gets bigger without you moving an inch. And if humans eventually do spread beyond Earth, even to small outposts, even to distant habitats, that would mean the candle doesn't just flicker in one place, it flickers in many places. That's not a movie ending, that's a long-term project. Now let's keep the story moving while we're still in that feeling. Because there's one last thing people forget when they hear Earth is tiny. Tiny things can be the most important things. A seed is tiny, but it carries a forest, and Earth, for all its smallness, might be carrying something even rarer than a forest. A mind, a witness, a creature that can look up, do the math, and feel the weight of the universe without collapsing under it. That is a strange kind of strength. And it's the kind of strength you only notice after you've zoomed out far enough to almost lose yourself, and then come back and realize you're still here. And you know what's wild? Even after all this zooming out, we still haven't hit the deepest punchline of scale. Because the universe doesn't just get bigger, it gets weirder. Out there, far beyond the Milky Way, there are regions of space that are basically running away from us. Not because they hate us, because space itself is stretching. The farther a galaxy is, the faster it seems to be moving away, like dots on a balloon as you blow it up. That's why some galaxies will never be reachable, no matter how good our rockets get. It's not a tech problem. It's a rules of reality problem. So when people say, one day we'll explore the whole universe, that sounds nice, but is not true in a literal sense. We can explore a lot. We can learn a lot. But there are parts of reality that will always be beyond our reach, like a horizon that keeps stepping back as you walk. That sounds a bit sad until you flip it again, because it means what we can see is already a miracle of access. Think about it. A species that evolved on one planet can look out and map the cosmic web, can measure the leftover glow of the early universe, can track galaxies so far away their light started traveling before Earth even existed. That should make you proud in a quiet way. It's like being born in a village and somehow learning the whole planet's geography by reading the wind. And the reason we can do that is because humans didn't just stare at the sky. We built tools that turned faint light into truth. Hubble gave us deep field views that looked like somebody spilled glitter across the darkness. The James Webb Space Telescope started pulling early galaxies out of the shadows, like a detective finding fingerprints under a special lamp. Ground giants like Keck Observatory in Hawaii and the European Southern Observatory keep feeding the machine with sharp measurements and careful spectra. Researchers at the Harvard-Smithsonian Center for Astrophysics keep turning those measurements into models that actually make sense. Even Voyager 1 is part of the same story. Not because it's exploring galaxies, but because it proves humans can send a little machine out into the dark and keep a conversation going across the void. Now let's make the scale hit in a relatable way again. If the entire history of the universe was one calendar year, humans would show up in the last minutes of December 31. All of recorded history would be a blink. Your life would be like a spark off a campfire. And yet, that spark can understand the whole year. That's the weird beauty of it. Now here's a truth that people don't like, but it makes the story stronger. Feeling small is not the problem. Feeling meaningless is the problem. Small is just size. Meaning is something else. Meaning comes from what you do with your time, your mind, and your planet. And when you look at Earth from this cosmic angle, you start to see meaning in very practical things. Protecting the atmosphere, protecting oceans, keeping peace, building science, teaching kids, taking care of people. Not because you're trying to be a hero, because life might be rare enough that you don't waste it. This is where the silence of the universe turns into a kind of pressure. Not scary pressure, responsibility pressure. If we are alone, then we carry the only known candle of awareness. If we are not alone, then we are still responsible for our own candle, because nobody is coming to babysit us. Either way, the job is the same. Keep the flame alive. Now, let's talk about that flame in real terms. Humans are fragile, but humans are also stubborn. We build, we fix, we learn, we adapt. You see that stubbornness in NASA engineering. A spacecraft breaks, a team finds a workaround. A probe is billions of kilometers away, still sending whispers, and people still listen. That mindset is a big reason we've learned anything at all. And the same mindset is why the search for life keeps going, even when it's quiet. Arecibo's legacy taught us how to listen. Other radio telescopes and surveys continue that work. People still talk about old ideas like Ronald Bracewell's probe concept not as proof of anything, but as a reminder that there are many ways intelligence could show up, and we might be looking for the wrong kind of footprint. Right now, we're like someone in a giant forest yelling hello once, then saying, guess nobody's here. That's not serious searching. Serious searching takes time, and we have barely started. Now, here's a point that keeps viewers engaged, because it's simple and kind of scary. Even if a planet has life, the universe can erase evidence fast. A civilization could rise, build cities, and disappear. After a few thousand years, their radio noise fades. After a few million years, even big structures get buried or broken. After a few 100 million years, a planet's surface can recycle itself. On Earth, plate tectonics constantly chews up old crust and reshapes the face of the planet. So even if the universe had many civilizations, the evidence might be faint, temporary, or hidden. So the silence doesn't prove emptiness. It might just prove how hard it is to catch a spark in a storm. Now bring it back to the main theme again. Scale. Earth is tiny, but Earth is loud in one way. It's chemically loud. It has oxygen, it has water, it has plants, it has biology changing the atmosphere. If aliens had a strong telescope and they looked at Earth, they might notice that something is off here in a good way. That's why atmosphere studies are such a big deal. It's the closest thing we have to sniffing another world from far away. So when you zoom out and then zoom back in, you start to see Earth as not just small, but noticeable. A tiny dot with a weird signature. A tiny dot doing something special. And that's why this video's main message hits hard if you let it. Earth being small doesn't reduce you. It reveals how lucky you are to have a home at all. Now, a quick moment of honesty, because people watching long videos need truth, not just wonder. Yes, you are small. Yes, the universe is huge. Yes, most of it will never care what you do. But you know what does care? Your family, your friends, your community, your future self, the people you haven't met yet, the kids who will inherit the results of what we build and what we break. So the cosmic view doesn't make daily life pointless. It makes daily life more serious in the best way. It makes you stop wasting energy on nonsense. Because when you remember how thin the atmosphere is, how rare liquid water is, how hard it is to keep life going, you start to treat peace and progress like real treasures, not just nice ideas. And at the end of the day, that's what the true scale of the universe does to a person. It doesn't just shrink Earth, it raises the value of Earth. It makes you look at a normal glass of water and think, wow, this is not normal at all. It makes you look at a sky full of stars and think, the universe is huge, but I'm standing on one of the few places that can wonder about it. That's not small, that's rare. So after all that zooming out, after all those numbers and distances and ancient light, you reach the part that hits hardest. Not because it's the biggest, but because it's the clearest. On the scale of the universe, Earth is basically nothing. A speck around an average star sitting in one arm of one galaxy, hanging in one strand of a cosmic web that stretches farther than your brain can picture. And yet, when you zoom in to what actually matters, Earth becomes the biggest thing you've ever seen. Because Earth is not just a rock, it's a living place. It's the only place we know where water falls from the sky, where oceans breathe, where forests push oxygen into the air, where minds wake up and ask questions like, how small are we really? That's the climax of this whole journey, not the size of the universe. The fact that something this small can notice it. Think about how crazy that is for one honest second. The universe is cold in most places, dark in most places, silent in most places. And inside that silence, on one tiny world, chemistry became biology, biology became brains, and brains became curiosity, and curiosity became telescopes, and telescopes became answers. Hubble showed us galaxies stacked behind galaxies like the universe had no end. James Webb reached even deeper, catching ancient light stretched into infrared. The Keck Observatory and the European Southern Observatory kept mapping and measuring from the ground, turning faint dots into real facts. NASA's Jet Propulsion Laboratory helped make space travel precise enough that we could send machines like Voyager 1 out into the dark and still hear them whisper back. All of that effort, all of that genius, all of that patience exists for one reason. Because we are trying to understand what we are doing here. And once you see Earth shrink to invisibility in the cosmic view, you stop treating it like it's replaceable. You stop talking about another planet like it's a backup phone in your pocket. Earth is not a backup. Earth is the only known lifeboat that works. And if the universe is truly full of life, then Earth is still precious because it's our home and our starting point. If the universe is mostly empty of life, then Earth becomes even more precious because it might be one of the few places where the universe is awake at all. Either way, the conclusion is the same. This tiny planet matters more than our egos. This tiny planet deserves our best thinking, not our worst habits. So when you walk outside tomorrow and you see the sky, remember what you're actually looking at. You're looking at an ocean so big you can't cross it, and you're standing on a rare little island that can look back and understand the waves. If you want more videos that make the universe feel real, click the next video on your screen now.